Scientific comparisons. Nuclear fusion versus nuclear fission. Nuclear fusion and nuclear fission are two distinct nuclear processes with significant implications for energy production and nuclear reactions. Let's explore the comprehensive comparison between these two phenomena. Definition. Nuclear fusion. Nuclear fusion is a process where two light atomic nuclei, typically isotopes of hydrogen, such as deuterium and tritium, combine to form a heavier nucleus, releasing an enormous amount of energy in the process. Nuclear fission. Nuclear fission involves the splitting of a heavy atomic nucleus, such as uranium-235 or plutonium-239, into two smaller nuclei, along with the release of a considerable amount of energy. Energy production. Fusion. Fusion is the process that powers the Sun and other stars, where hydrogen nuclei fuse to form helium, releasing vast amounts of energy in the form of light and heat. It has the potential to provide an almost limitless and clean source of energy once it becomes commercially viable on Earth. Fission. Fission is the process used in nuclear power plants to generate electricity. The controlled splitting of atomic nuclei produces heat, which is used to generate steam, turning turbines to produce electrical power. It currently supplies a significant portion of the world's electricity but produces radioactive waste. Fuel. Fusion. Fusion requires isotopes of hydrogen, primarily deuterium and tritium, which are abundant in seawater and lithium. These fuels are non-radioactive and more plentiful than fission fuels. Fission. Fission uses heavy elements like uranium-235 or plutonium-239 as fuel, which is relatively scarce and requires a complex and expensive enrichment process. Fission fuels are also highly radioactive, producing long-lived nuclear waste. Safety. Fusion. Fusion reactions involve isotopes of hydrogen, which are not readily radioactive. The fuel supply is inherently safe, and there is no risk of a runaway reaction or meltdown like in nuclear fission. Fission. Fission reactors carry inherent safety risks, such as the potential for meltdowns, radioactive releases, and long-term storage challenges for nuclear waste. Waste. Fusion. Fusion reactions produce helium as a harmless byproduct and do not generate long-lived radioactive waste. Fission. Fission produces high-level radioactive waste that requires secure long-term storage and management to prevent environmental contamination. Temperature and containment. Fusion. Fusion requires extremely high temperatures and pressure to overcome the electrostatic repulsion between atomic nuclei. This process is challenging to achieve and maintain in a controlled manner on Earth. Fission. Fission reactions can be self-sustaining under controlled conditions, making them relatively easier to maintain in nuclear power plants. Summary. Nuclear fusion and nuclear fission are both nuclear processes with the potential for energy production, but they differ significantly in their safety, fuel supply, waste generation, and technical challenges. While nuclear fission is currently utilized in nuclear power plants, nuclear fusion holds the promise of clean, abundant, and safe energy generation once the scientific and engineering challenges are overcome. Enjoyed the video? Don't forget to subscribe, share it with your friends, and give it a thumbs up if you found it valuable.